Welcome back, everyone. Today we're going to get an introduction to relations or relationships or correlations. Those are all what we're calling relations, and a very special type of relation, which is known as a function. This will get you enough information to be able to do Q2, domain and range of relations. Okay, so what's a relation between two variables? Well, it's a situation where one event affects another, such as, rain makes the grass grow. Um, the more you lift weights, the stronger you get. The more you study, the better you do on your schoolwork. Um, those are where one event affects another event. That's what a relationship is. Another example would be where, in children, you know, anyone under 18, typically, the older you are, the taller you are. Most 15-year-olds are taller than most 5-year-olds. So the event of your age is going to have an impact or an effect on your height. So older equals taller. Not an exact thing, but there is a relationship between those two things. But some relations are functions, and a function is very special in that it means that whatever your cause is, your input, has only one possible result. So every 5-year-old is exactly 3 feet tall or 4 feet tall. Of course, that's not true, but that's what a function would be. Every cause has only one possible result or output. A child's age and height are not a function since there's not only one height for one age. So that's not a function. A function might be where if you have a gumball machine and you get 3 gumballs for every quarter you put in, 1 quarter would get you 3 gumballs, 2 quarters would get you 6 gumballs, and so on. That would be a function. You cannot know the height of a child simply by knowing his or her age. Of course not. So for in a function, the actual definition that we're using is for every input, there is one and only one output. For every input, there's one and only one output. And in math, we know those inputs typically is x. That's what's on that x-axis. Okay, domain. The domain is all the possible inputs. All the possible inputs. We'll see an example of that here in a moment. The range is all the possible outputs, all the possible y's. So let's see what that looks like. An example. So here's 3 points on a graph, 3, 5, 7, 2, -4, and 1. All of the x values, 3, 7, and -4, are going to be the domain. That's simple. There they are. The answer is the domain is -4, 3, and 7. The range, on the other hand, is all the possible outputs, all the y's, 5, 2, and 1. So the answer for that's going to be range is 1, 2, 5. If you don't see it as a list of ordered pairs, you might see those same ordered pairs in a table. Same thing though. Domain -5, 1/2, 22. Range -2, 4, and 10. There they are. Or you might see it on a graph. Well, if you see it on a graph, first you need to know what the points are. So you go ahead and label your points. This one's 2, 3, 5, 0, 9, 4. So the domain is going to be 2, 5, and 9. 2, 5, and 9. Those are all the x values. And the range is going to be 0, 3, and 4. Those are all the y values. Something to keep in mind when you're doing this, standard practices, you put them in numerical order and you don't repeat a number. So if you see two x's that are 4, you wouldn't list it twice. Um, and you would go 3, 4 instead of 4, 3. You'd put it in numerical order. Now, IXL is not going to count off for that. That's just a habit that I would like for you to get in. If you have any questions, just go ahead and give me or send me an email, and we'll see if we can get it straightened out. Thank you very much.